Welcome to the video lecture based on utilization of electric power, paper code EE702. Today's topic is Introduction to Electrolytic Process. Myself, Runrum Banerjee, Assistant Professor of Electrical Engineering Department, Dr. Sudhir Chandrasur Institute of Technology and Sports Complex. Previously, this institute was known as Dr. Sudhir Chandrasur Degree Engineering College. In the paper "Utilization of Electric Power", this topic is the last module of entire syllabus of utilization of electric power. And this module is named as electrolytic process. And in this module, we will learn how the electrolytic process can be done, what is the basic law about it, and how the different kinds of electrolysis process are actually there and what are the benefits, what are the factors affecting when we are talking about electrolytic process. So let us start with the introduction to electrolytic process. The fact that electrical energy can produce chemical changes and a process based on it called electrolytic process are widely used for extraction of pure metals from their ones, such as aluminium, zinc, copper, magnesium, sodium, etc. Manufacturing process of various chemicals such as caustic soda, potassium permanganate, hydrogen, oxygen, chlorine, etc. Electrodisposition of metals including electroplating, electrotyping, electroforming, building up of worn out parts in metallurgical, chemical and other industries. Though the various processes of mentioned are different in apparent detail, but fundamentally they are alike, being based on the principle of electrolysis. So here a diagram is shown of electrolysis process. We can see there are two plates, one is anode, another one is cathode. And electrolytic and and electrons are flowing. And here the Cu, copper and CO4. Here electrolyte as used as CuSO4. So the Cu plus ions and CO4 minus ions, negative ions, are moving in this electrolyte and ultimately through electrolysis process our energy is developed. So in later on stages we will see that what are the things actually happened in electrolysis process. Let us see the basic principle of electrolysis. In nature, atoms of electrolyte chemical compound are closely bound together, but bond becomes weaker when dissolved and the molecules of the electrolyte split up into two types of ions carrying electric charges called cations and anions and moving freely in the solution. Now, if two electrodes are dipped into the electrolyte and connected to the DC supply, ions associated with positive charge, cations, and moving freely in the solution and attracted by the cathode terminal of the supply associated with negative charges are known as anions, and moving freely in the solution are attracted by For example, when copper sulfate CuSO4 is dissolved in water, immediately it gets dissociated into positively charged copper ion Cu++ and negatively charged sulfur ions, that is SO4 minus minus moving freely in the solution. And if a potential difference is applied between the two electrodes immersed in the solution, the positively charged copper ions will move towards the cathode and negatively charged sulfur ions will move towards the anode. Each of the positively charged copper ions reaching the cathode will take two electrons from it and become a metallic atom of copper. And similarly, each of the negative charged sulfur ions reaching the anode will give off two electrons to it and cease to be anion. Thus, the electrons will move from anode to cathode in the external circuit and constitute flow of current from anode to cathode in the electrolyte. Only to second pumping electrolysis. The mechanism of anode and cathode movement of positive and negative ions basically form the electrolysis process. As mentioned previously, each positively charged copper ion on reaching the cathode takes two electrons from it, becomes atom of metallic copper and deposit there. Similarly, each negatively charged sulfur ion on reaching the anode gives up two electrons to it and becomes SO4 radical, but since SO4 radical cannot exist in the electrical neutral state, so it will attract the anode and will form the corresponding sulfate of the material of the anode. For example, if the anode is of copper, then copper sulfate CuSO4 will be formed. But if the anode is of such a material which cannot be attracted by SO4, for example, if the anode is carbon, the SO4 will react with water and form sulfuric acid and liberate oxygen according to the chemical reaction, like 2SO4 plus 2H2O equals to 2H2SO4 plus O2. The whole process described above is called electrolysis, and the effect is that the copper gets dissolved from anode and deposited on the cathode. During the process, there is no accumulation of charge at any point in the circuit. The copper deposited at the cathode is exactly equal to the removed from the anode. So here the materials which we are using as anode, as electrolyte, those are very important for depositing of the metals. So here the Faraday's law of electrodeposition. The laws governing electrolytic process were formulated by Michael Faraday, an English scientist, and are known after his name. These may be stated as follows. Faraday's first law. According to this law, the chemical disposition due to flow of current through an electrolyte is directly proportional to the quantity of the electricity. According to this law, the chemical deposition due to flow of current through an electrolyte is directly proportional to the quantity of electricity, coulombs, passed through it. That means the mass of chemical disposition M directly proportional to quantity of the electricity Q. That is M directly proportional with IT or M equals to JIT, where I is the is the steady current in amperes from the constant of proportionality and is known as electrochemical equivalent of the substance. If I equals to 1 ampere and t equals to 1 second, then z equals to m. Thus, electrochemical equivalent Z of substance is defined as the amount of the substance deposited on passing a steady electric current of 1 ampere for 1 second through its solution. It is usually expressed in terms of milligrams per coulomb. The SI unit of electrochemical equivalent Z is the kilogram per coulomb, that is kg per C. So that is the Faraday's first law. Now we will go to Faraday's second law. This law states that when the same quantity of electricity is passed through several electrolytes, the mass of substance is deposited are proportional to their respective chemical equivalence or equivalent weight. This law states that when the same quantity of electricity is passed through several electrolytes, the mass of substance deposited are proportional to their respective chemical equivalence or equivalent weight. That is known as Faraday's second law. Now we will consider one numerical problem related to this. So, let us consider the problem. In a copper sulfate voltmeter, the copper cathode is increased in voltage when the current is maintained was constant that atomic weight of copper is 63.5, atomic weight of hydrogen 1 and atomic weight of silver is 108. Electrochemical equivalent of silver is 0.001118 gram. Solution. Mass of copper deposited M equals to 50 gram. Time of flow of current, that is 2 hours. That is 2 into 60 into 60, 7200 seconds. An electrochemical equivalent of silver is given in the problem, that is 0.001118. This one. So we can write it as 111.8 into 10 to the power minus 8 kg per coulomb. Chemical equivalent of silver, atomic weight divided by valency, that is 108 by 1. So chemical equivalent of copper is 63.5 divided by 2, that is 31.75. So that is the chemical equivalent of copper. Now the thing is, we have to calculate the value of this current. So we will go to the next part of this problem, that ECE of copper, that means electrochemical equivalent of copper, that is ECE of silver into chemical equivalent of copper divided by chemical equivalent of silver. Basically, silver is the parameter to calculate the electrochemical equivalence of any material. So silver is taken here and our ECE of copper is 32.867 into 10 to the power 8 kg per coulomb. And the strength of current, we have directly put it the formula, that is I equals to m divided by z into t, that is putting the value of m, that is 50 into 10 to the power 3 minus 3 divided by 32.867 into 10 to the power minus 8 into 7200. That is, our actual answer is 21.13 ampere. So that is our answer. Next, we are considering another problem, that is find the thickness of copper deposited on a plate area of 0.00025 meter square during electrolysis. If a current of 1 ampere is passed for 100 minutes, density of copper is 8900 kg per meter cube, and the EC of copper is 32.95 into 10 to the power minus 8 kg per coulomb. So, for solution, we can see that EC of copper is given, current strength I is given, and copper density D is also given. So we know that the time, that is 100 minutes is given, so we have converted it to second. And mass of copper deposited, we have directly used the formula, that is m equals to ZIT. Putting the value of Z, I and T, we are getting the value of mass. And volume of copper deposited, definitely it will be m divided by d, or that means density of the copper. So the volume will be 0.222 into 10 to the power minus 6 meter cube. And thickness of copper deposited, that will be V by A. So putting the value of the volume of copper divided by A means that. So putting all this value, we can calculate the thickness of the copper deposited. Okay, so in that way we can calculate the thickness of copper. So up to this much for today's class. In next class we can discuss much more related to this, and we will continue with the same topic in my next lecture also, that is electrolysis process. There we will discuss about electrodisposition, that means how different kinds of metal actually deposited using electrolysis process. That thing we can see there. So this total lecture I have taken from the book of J.B. Gupta. You can go through that book, and that is very helpful and very good book in this regard. And electrolysis process is basically used for different kinds of metal extraction in industry. Like we can extract zinc, we can extract aluminium, we can extract copper, we can extract gold even, or many kinds of metals are generally extracted by electrolysis process. So definitely electrolysis process is very important, and it is very helpful in case of extraction of metals. So definitely electrolysis process is definitely easier one compared to other processes, and definitely I will tell you, generally from this chapter you are getting questions like short notes. So process will be very easy to answer for you, and definitely you don't need much more time for go through these chapters. So definitely I will tell to use this chapter for easier understanding and easy answering. So you can also tell Some questions I can tell you related to this, like what is electrolysis? Basically, electrolysis means the breaking of a substance into ions by flow of electric charge through it is known as electrolysis. Or write some applications related to electrolysis. Electrolysis application means extraction of some metals like aluminum, zinc, copper, magnesium, sodium, or many kinds of manufacturing chemicals such like caustic soda, potassium, permanganate, hydrogen, oxygen, chlorine. Like these metals we can extract from electrolysis process. So there will be lots of questions can be asked from electrolysis process, and it is very easy to understand and easy to remember. So definitely I will tell you just go through this chapter and that will be very helpful for you. Thank you all for listening my lecture.